How did early circuit simulation work with punch cards? Imagine a time when engineers couldn't just click a button to test a circuit. Instead, they used punch cards to tell computers what to do. It might sound old-fashioned, but it was a huge step forward. Early circuit simulation involved encoding all the circuit data and instructions onto stacks of punch cards. Each card was like a tiny message, with holes punched in specific spots to representing numbers, commands, or circuit details. These cards were carefully prepared by engineers, who punched about 80 characters of data on each one. For complex circuits, they used hundreds or even thousands of cards, arranged in a precise order because the sequence mattered a lot. Once the cards were ready, they fed them into a card reader attached to a computer. The card reader would scan the holes and convert them into electrical signals that the computer could understand. The early simulation software, often written in languages like Fortran or assembly language, then processed these signals to perform calculations. These calculations could include voltage levels at different points, current flows, or how the circuit responded over time. Because computers then had limited power, the models used in these simulations were usually simple. They focused on linear or small signal analysis, which meant they only looked at basic behaviors. Correcting errors was a slow process because if a mistake was found, the engineer had to punch a new card and replace the faulty one. This process was time-consuming and prone to errors, but it was still a major leap from manual calculations. Early circuit simulation with punch cards helped engineers move from manual, paper-based calculations to digital analysis. It laid the foundation for modern electronic design automation tools. These early methods allowed engineers to verify designs, predict how circuits would perform, and troubleshoot issues before building physical prototypes. This saved a lot of time and resources. It also helped engineers develop skills in programming and using computational tools, skills that are essential today. So, even though it was slow and cumbersome, punch card-based simulation was a key step in making electronic design faster and more reliable.